recording this for the other kids. I'm gonna put it up on the YouTube. Alright, I'm thinking you should be done with 1.1 and you're probably busy with 1.2 now. So I'm gonna start with 1.1 now. Alright, so those are your two x values. Hi Drew, welcome. We've already gotten started. Actually, we've done the first question. So you can also join us. I think people are busy doing the second question. And remember with this one, that's that question where you kind of need to check your answers at the end. You need to check those two x values to see which one is correct.
Yeah.
I'm going to just mute you, Drew. Unless you have something to say, you can always unmute yourself.
Okay, I'll just mute myself.
Okay, cool. Thank you. Just so there's no clutter. Alright, I'm thinking by this point you should have finished this one. You can try 1.3 yourself. I will speak through it though. So here what am I doing? I'm squaring on both sides. Remember, I've done these type of questions before. So it's 2x plus 1 is equal to this. You have to write both brackets like that. 2x plus 1 is equal, and foil those brackets, x squared minus x plus 1. 2x plus 1 is an x squared minus 2x plus 1. And at this point you should be dragging everything onto one side. So x squared minus 2x plus 1 minus 1, and that's how it looks. So x squared minus 4x equal to 0. Welcome, Morgan. We've already gotten started. I think some of them are probably busy with 1.3 now. I'm marking 1.2, so you can jump right into it. So as I was saying, if you factorize this, you take out your x as a common factor, x minus 4, and you actually get x is equal to 0 and x is equal to a positive 4. But if I do my check, I'm just gonna move this side just so I can do my quick check here. If I do my check, which one does not work? So the root of 0 plus 1 equal to 0 minus 1. This gives me a root of 1, and 1 is clearly not equal to minus 1. So that one does not work actually. Hello Jensen. I'm busy marking 1.2. So I checked the 0 does not work. Let me just check the 4. 4 in brackets plus 1 is equal to 4 minus 1. That's an 8 plus 1, which is a root of 9. And this one does work. So I know in normal algebra when we're solving, I always tell you that when you're square rooting, remember that it's a plus minus. But in this case, we just square root like normal. So I know it's counterintuitive, and it's like, okay, Mr. Malachi, when do you need to do the plus minus and when do you not? So when you're checking, that's when you don't really need to do the plus minus because we're not actually solving for anything. We're just checking, and a square root of one is just the positive one. So yeah, that I hope that makes sense. Morgan, I hope that makes sense. Does it make sense for you?
Yes, it does.
Okay, cool, excellent. All right. So the only one that would work is that positive 4. And so that's why we rejected the positive 0 or the 0. That's why we rejected the 0. Alrighty, then let me do 1.1.3. If you've done it already, you can keep working with the other questions. The point is that you move forward. I'll move behind you guys. Unless you struggle, then obviously. So with this one, the bases are already the same, so I can already make the exponents equal to each other. Remember, that's how you solve exponential equations. If the bases are the same, I can just equate the exponents. So I'm making that equal to 27, right? But this, how do I work with that? That is just an x that is timesing an x that has an exponent of a half. And where am I getting that half? Remember, if this is a square root of 2, this 2 is actually dividing that exponent there. And that current exponent is a 1, so it's a 2 divided by a 1. And that's how I get that half. And all of this is equal to 27. And those bases are the same. I can add now the exponents. So 1 plus a half would give me an exponent of 3 over 2. 1 plus a half is 1.5, which is 3 over 2. Right? So once you've gotten like this, then to get rid of this exponent here, you need to do the inverse of that exponent on both sides. So the inverse of that exponent is a 3 over 2. That's the only way it can actually cancel with that. No, it's not a 3 over 2. Sorry, did I say 3 over 2? I meant 2 over 3. So you do exponent of 2 over 3 on both sides. I hope you guys can see that. Sorry about the small writing. And so that's that guy cancelling, and so we're left with an x and a 27 to the power of 2 over 3. You can at this point plug that into your calculator and you will get what that answer is. And let's check. 27 to the power of 2 over 3 is a positive 9. And there we go. All right, any questions about that though? Anyone who does not understand what I was doing there? All right, I'm guessing everyone is fine.
I'm good.
You good?
I'm
Okay.
just wondering. So we can use a calculator for this, right?
You can, but at certain points. So you can't straight up use a calculator straight getting to the 9, but at certain point, like how I used a calculator for the 27 to the power of 2 over 3, that is fine. But I can't imagine you using a calculator straight from the top to the bottom. But in certain parts of it, you can definitely. Yeah.
Okay.
But by the way, if we didn't know what 27 to the power of 2 over 3 is, we could have changed it back into a root 3 with the 27 squared, and you work with that, and you should eventually still end up with a 9. So that's another way you could have solved that. But yeah, you definitely can use a calculator for that. Okay. I'm gonna move on to 1.4 then. Is there 1.4? Yes. So maybe let me give you a moment, a couple of minutes. I will start marking 1.4 at like 20, not 20 past, maybe at like 18. So try 1.4 yourself if you haven't yet. I think it's a very easy quadratic equation. You don't need a quadratic formula there. You do need to plot it though, so you can actually see what is happening with that inequality. And so yeah, try it out, guys. So there is going to be some parts of this paper that we don't do because we haven't covered yet. Like some of the functions we haven't done, some of the probability we haven't done. So yeah, we're not going to do the whole paper right now. Eventually we should be able to do all these papers completely. Alright, I'm gonna get started on 1.1.4. X squared minus 2x minus 8 less than 0. You can just easily factorize this. Factors of 8 that add to give me negative 2 is a negative 4 with a positive 2. And so my critical values are a positive 4 and a negative 2. And how you represent this is a negative 2 there, a positive 4 there. It's a smiley shape because of this a value is a positive. So my graph goes up like that. And my inequality says less than, so I'm looking for this range here below the graph. How do I represent that? Negative 2, x is greater than that negative 2, but x is less than a positive 4. And there we go. Alright, I'm gonna also move on to 1.2.1. We're given f of x there, and you're asked to solve f of x where it's equal to 0. So they're basically saying take that equation there and make it equal to 0 and solve for x. So I think this one might need a quadratic formula. I'm looking at it and I'm like, 35, can I try doing that other type of factorization I like? 35 factors of 35. 7 and a 5. Okay, I'm just gonna use the quadratic formula. So a is 5,
It's a bunch of weird small places.
Sorry?
It's
And
a bunch of weird decimal places.
okay, yeah, then I'm gonna definitely need my quadratic formula. Alright. Thank you for that. So there is my A, B, C, and A, B, and C. So the x value, the first x value, and the second x value. So I'm gonna try. Alright, so the first one is 0.73. 0.73 rounded off. And the second one is negative 9.23. So please round off correctly. At this level, guys, you can't be making rounding off mistakes. In metric level, what they do is they only debit you once for incorrect rounding off. So if you round off incorrectly here, you'd lose that mark, but then moving forward they'll just kind of give you kind of, you know, help you along. So yeah, please don't be that person that needs help. Just get it right. Yeah. And so the second one says 1.1 2.2 says hence or otherwise calculate the value of d if this guy has equal roots. Ooh, I like this because I taught this at one point. So they're saying we have 5x squared plus 6x minus d and equal roots. Again, remind me, people, what does delta need to be equal to for equal roots? What does my discriminant need to be equal to?
0.
Equal
0.
roots, right? Yes. So equal roots, remember the discriminant, which is delta, which is equal to b squared minus 4ac. It needs to be equal to 0 for equal roots. Alright, so you just need to find what your a is. Your a is 5, your b is 6, your c is that negative d, and that's the guy you're going to substitute in there for your discriminant. So you're going to say open bracket 6 squared minus 4, the 5, and then negative d, and all of this is equal to 0, and you're solving for that. So it's a 36 negative times a negative will give me a positive, so that's a positive 20d equal to 0. Take the 36 over negative 36, divide by 20, divide by 20, and so d is whatever fraction that is simplified. I don't know, so I'm going to try it. It's a 9 over 5. So that's the value of d. Alright, any questions about that though? So that should also be fairly straightforward. If you had forgotten what equal roots are, then this was going to be a perfect time for you to go back onto your notes, check what equal roots mean again, and you should be able to see what I just did now. Alright, so moving forward, you guys should be, I'm guessing, way further than me now. Ooh, simultaneous equation 1.3. So x minus 2y is equal to negative 3. xy is equal to 20. So I'm going to use equation 1 and I'm going to make equation 3 out of it, which looks like that, by taking the 2y over, and I'm going to substitute it into 2 sub 3 into 2. So I just write this. You don't really need to, but just always write this so that my examiner knows what I'm doing. So yeah, the way I just always learned and enjoyed doing math is I put some English with it, you know? It's not just numbers floating on the page. I'm telling my examiner exactly what I'm doing there. So what happens here? This y would multiply into that bracket. Negative 3y plus a 2y squared is going to give me a 20. You would therefore grab everything onto one side of the equation like that, and this is just a quadratic that you need to solve. Is it one of those that give you decimals? 2 times the 20 will give me negative 40, negative 40, 4 and 10. Now 5 and 8. Oh yeah, that one does work. So I'm gonna use that special factorization method that I have. I'm timesing the 2 across with that variable there, with that constant, sorry, and it gives me negative 40, and the factors of 40 that add to give me that guy is a negative 8 with a positive, sorry, it's a y, with a positive 5. And so I need to remember, so if you're gonna use this method, guys, please remember to divide. Actually, don't use the method because I know you will forget to divide. Just use your quadratic formula, honestly, because yeah, remembering to divide like that, it's very hard to remember that. I always do, but I'm scared you guys might forget. Alright, so these are my 2y values done. So now I can find my 2x values using equation 3. Plus 2, the first one, substituting the 4. Negative 3 with the 8 gives me a positive 5. The other one, negative 3 with a negative 5 over 2. Yep. And what this gives me, negative 3 minus 5, this gives me a negative 8. So those are your 2x values and these are your 2y values. Sometimes what I like doing is I like putting them close to each other like that. This x value corresponds with that y value. This x value corresponds with that y value. Just put them close like that, close to each other. Alright, I think that should be fairly straightforward. If you didn't get it the first time, it's fine. You can try it again. The whole point of these sessions is to just allow you a safe space to do these math stuff. See where you're getting wrong, what you're getting wrong, and how to fix your problem. So now we're getting into some exponents. And I know you guys haven't seen exponents in a while. So this might be a section, a section that some of you might struggle with. Should I jump straight into it or should I wait? I think let me wait a bit. Let me wait maybe 2 minutes.
Can you go back up to 1.2.2?
Yes, I can.
Thank you.
There we go. Oh, actually, it's a mistake here. I'm noticing now. I forgot the negative. Do you see I'm dividing a negative 36 with a positive 20? It should be a negative 9 over 5. Sorry about that. It should be a negative 9 over 5. You'll let me know once you're done, Hannah. Once you're good.
Yeah, I'm good.
Okay. Alright, I wanna then jump into this one then. So here you just need to simplify these by changing these guys into the same base as 2. And the way you do that is you use your calculator. You just plug in 4, you say equal to, then you say shift and fact. And it's going to change that 4 into its prime base or its prime product. So 2 stays the same because it's already a prime number. But the 4 changes into a 2 to the power of 2. And you do the same with the 8. Plug in 8 into your calculator, equal to, shift and fact. There's a button that has FACT. That's the button you press. It usually has also those commas for minutes and blah blah blah. So that's the button you usually press. 2 to the power of 3. And you get n minus 1. And now these 2's are gonna distribute with that guy outside. This 3 also is gonna distribute with that guy outside of the bracket. So what I will end up getting is a 2 to the power of n plus 2 times a 2 to the power of 2n plus 2. So make sure that 2 multiplies the n and multiplies the 1. And then at the bottom the same. The 3 multiplies the n to give me a 3n. And it multiplies the 1 to give me a negative 3. Then at the top you're going to use your first law. And that law says if the bases are the same, if you get x to the n timesing an x to the m, you'll just have x to the power of n plus m. That's the first law of exponents that you would have learned. So that's what's happening at the top. But since I'm adding binomials, I'm just going to quickly add them in my brain. N plus a 2n would give me a 3n. A 2 plus a 2 would give me a 4. And all of this is divided by 2 to the power of 3n minus 3. And now what am I going to use? I'm going to use the second law that you learned that says if I have two things that have the same bases that are dividing, I can subtract those exponents. So that's the second law that you would have learned. So that's exactly what I'm going to apply there. But when you're subtracting this, you have to be careful because you're subtracting a binomial with a binomial. So it has to be 2 to the power of 3n plus 4 minus with brackets like that. I sometimes like writing it like that. And then I need to remember that that negative belongs to the 3n and it belongs to the minus 3. And so what I get is a 2 to the power of 3n plus 4 minus 3n plus 3. And so this gives me 2 to the power, the 3n's cancel. And you just have 2 to the power of 1, which is just easily a 2. Alright, I'll just scroll and keep it here on the screen for you guys to write it down if you still need to. And if you have questions, you can always ask people. Just lift up your hand, ask, or maybe just unmute yourself and ask.
Is it not 4 plus 3?
Where?
It's at the last
Ooh,
step
ooh,
because
ooh,
you
ooh, ooh.
time the negative in, so then it should be 2 to the power 7.
Yes, sorry. Okay, I don't know why I was subtracting. Yes, it is a 4 plus a 3 that gives me a 7. Yes. So 2 to the power of 7, what is that? I don't know. Isn't it 72? I think it might be 72. 2 to the power of 7. Oh, 128. 128. Yes, thank you for that, Hannah. And sometimes my brain just works super fast that I miss these type of things.
So for these questions, it says simplify without using a calculator, but I don't know what 2 to the power 7 is without using a calculator. Can I still use it?
Yeah, you can still use a calculator, yes.
Okay.
And basically moving from here, like the 2 to the 7 to there, if you just write 128, there's no way your examiner can tell that you use the calculator. What if I can assert that I do know it's 128? So yeah, the whole point of saying without using a calculator is to say don't just plug that guy in, of which you either way you can't plug in that guy and go straight to the answer. Even if you wanted to, you can't because it has those exponents of n's. But yeah, that's what they mean by do not use a calculator. But there's going to be certain parts where you kind of do need to use a calculator, and that's one of them. Alright, I hope that is clear. I'm going to move on to the next one. I'm not going to wait anymore. I'm also pushing the time. We do only have these 2 hours, and we need to finish as much as we can. What does the next one say? Ooh, the next one is these roots, a lot of roots. With this one, any ideas though from the audience? Anyone that could crack this? Did I copy that correctly? This is a plus, this is a minus. Yeah, I think I got it correctly. Yeah, that seems correct. Alright. So what I'm going to do is I'm going to remember my law. And this law says that if I have a root of x that is multiplying a root of y, I could just put these guys under one root and multiply them. It's such a law. One of your exponential laws says something like that. Or if it's not a law, I have mentioned something like this to you. So that's what I'm going to do. Since these guys are all multiplying, I'm going to put them all under one big root. Right? Actually, even better. But yeah, let's do one big root. And then I'm going to do these two brackets. And inside of that bracket, we have this x plus the root of 2x minus 1 with the x minus the root of 2x minus 1. So at this point, I could FOIL out that guy. But another thing I'm going to remember. So yeah, with all these exam papers, you need to remember all your rules. Another thing I'm going to remember is that if I have bracket that says a minus b and an a plus b, if I have brackets like that and I were to FOIL out this bracket, this will always come out to say a squared minus b squared. It will always come out like that. And how do I remember that? Because the difference of two squares, if I factorize the difference of two squares, I always end up with these two brackets. One that has a negative and one that has a positive. So me remembering that, I see that, oh, this one is positive, this one is negative. So essentially, I'm just squaring the x, right? I'm squaring the x, getting an x squared. And essentially, I'm just squaring that bracket. And if I square that bracket, I'll just get the minus of a 2x minus 1. Do you guys see what I just did there, right? Are we all good with what I just did there?
Yep.
Yeah.
Yeah. And take note of the minus. I put a minus in between there, and it has to be a minus. It can't be a plus. Again, why? Because of this rule I just said to you now, the difference of two squares, that whenever you would multiply this out, you'd always end up with a minus there in between them. So that's why I have this minus in between them. And at this point, I could just distribute that minus into the second bracket. So it's x squared minus a 2x plus a 1. And that's a trinomial. Factors of 1 that add to give me a negative 2 is actually x minus 1 and an x minus 1. That bracket is the same bracket. I can write it twice. X minus 1 with the squared. This squared and this root cancel each other. So I'm left with an x minus 1. And there we go. That's how you go about solving that. But then again, like I said, at this point here, you could FOIL. You could still FOIL if you don't know a difference of two squares and the fact that it gives you this guy, or if you don't remember at that point and you're rushing and you're doing all these things, you could just FOIL and you would notice that, oh, those two brackets or those two terms in the middle, those cancel each other, and ultimately you will still land up with that guy. And if you land up with that guy, you should still land up with that guy if you distribute correctly, and it should still take you there. All right, I think I've said enough about that. I'm going to move on to the next one. The next one we're given 2.2.1 says we have P, and P is equal to the root of 5 over x plus 2 plus an x over 3. And they say for which values of x will the P be a real number. So remember what real numbers are. Real numbers are every single number that is not non-real and that is not undefined. Right? So something that was going to make this non-real is if inside of that root I had a negative. Remember that guy? If inside of the root I have a negative, how do I put this? I think the best way is to put it like this. Underneath a root, this would make it non-real. And what actually makes it undefined is if I was dividing by a 0. That makes it undefined. So I need to use the knowledge of this to say, okay, cool. I need to make sure that this guy then has to be positive, because if he is negative, then he's going to be non-real. So if that root there can be positive, or that fraction inside of the root can be positive, then that would definitely ensure, positive isn't like greater than 0. That would definitely ensure that I am getting sorry, I just got an alert. Alright, that will definitely ensure that I'm getting a real root for P. And if you solve this, how do you solve that? Do you multiply that side by 0? No, you can't do that. Okay, do you flip? Let me just check. How do you solve that again? Alright, so what you do is you kind of invert it. Right? You take this to be at the top, and you invert the second one as well. But if you're inverting a 0, you're still gonna get a 0. So essentially we're saying the x plus 2 needs to be less than, or no, greater than 0. Right? And then once you solve for x, you just take this to the other side, and this is a minus 2. So that's what they did. They just inverted it, and they got that. Got rid of the 5. And yeah. And yeah, this is the values of x. And it also correlates with that other one that I was talking about, this one here, the undefined one. So if that bottom guy is a 0, if you take that denominator and you say it should not be a 0, right? So that means x should not be a negative 2. And there we go. Yeah. Alright, what does the next one then ask from us? Show that P is rational if x is equal to 3. Let me just rewrite it again, 2.2.2. Oh no, the other one is the other way around, sorry. The x is there over 3. Alright, so let's substitute that value of 3. And what you were getting underneath the root is a 5 over 5 plus a 1. And this guy is just a square root of, remember p on this side, a square root of a 1 plus a 1. And that guy just gives me a 2. So clearly that is a rational number. All right, any questions about this though? I think what you needed to remember though is these parts here, these things that you learn. I think you learned these in grade 10 and so. To say a non-real is when you're square rooting a negative, undefined is when you're dividing by 0. I see we have 10 more minutes before the call ends. Actually, the call will end abruptly at 6. So don't be alarmed. 2.3. And then we're going to come back again at 10 past 6, ne? To finish up anything that we haven't. Let me do 2.3 and then I'll start some of the pattern questions and then we'll see how far we get. So this is to the power of 2005, 15 times 5 to the power of 2019. And we're asked to calculate the sum of the digits of this guy. This is a very weird question. But yeah, remember how I said in the beginning, actually last year, I think I mentioned this last term, sorry, not last year, last term. And I was like, there's those level 3 type questions that are gonna literally separate the B candidates with the A candidates. So this is one of those questions where you don't really learn something like this in class. You know, it's one of those questions where, yeah, you either have seen it before or you actually don't know what to do type of thing. So luckily I'm gonna do it now. So hopefully next time you see it again, you're gonna know what to do. But yeah, these are those type of questions. No one really teaches you these. So I'm gonna keep the 2015, right? 2 to the power of 2015. But this one, I'm gonna change it to be a 5 to the power of 2015. That is timesing a 5 to the power of 4. And how am I doing that? Remember the rule, same bases, you add the exponents, right? If these guys are multiplying and the bases are the same, you add those exponents. But similarly, you can move from things that are added to you splitting it up like that. So essentially in between this, what I'm doing is I'm writing that 2019 as a 2015 plus a 4. I'm essentially writing it like that first, and then now that I have it like that, I'm splitting it up into this. I hope you guys are hearing me, right? I'm first writing it as a 5 to the power of 2015 plus 4 to give me the 2019. And then I'm splitting it up by moving from this law back into that law where these bases are separate now. And once they're separate, then I can therefore work with these ones here. So those ones have the same. So let me put the other guy in front. These ones have the same exponent. So I can technically multiply the two of them to the power of the same exponent like that. And therefore, what law am I using there? There's also a law to that. That says if you have an x and a b that are multiplying inside and they have an exponent of something, let's say an exponent of a, then this a belongs to the a and it belongs to the b, giving me an x with the a with the b to the a. So technically I'm also doing the same, saying the exponents are the same. I want to move back now to them being into one bracket and them having the same exponent like that. And then at this point, what do? A 5 to the power of 4 and the guy inside is a 10. 2 times 5 is a 10. And a 5 to the power of 4, let me just evaluate what that is on my calculator. 5 times 5 times 5 times 5 is a 600 to 5. And this 10 to the power of 2015. If you times any number with a 10 to the power of whatever exponent it is, you're literally just adding that many zeros to it. So literally to this 625, I am adding 2000 and some and 15 zeros to it. So you can imagine I have 2015 zeros going all the way. But I'm not going to write it out. But remember what they wanted from us. All they wanted from us is what is the sum of the digits. So literally I'm noticing that all the other digits are zeros. So since all the other digits are zeros, then the only ones that actually affect the sum is just the 6 there, the 2 there, and the 5 there. And a 6 plus a 2 plus a 5 just gives me, what is that guy? 830. And there we go. So the sum of all those digits is actually 13. I don't know if that makes sense. Like, raise your hand if it makes sense, guys. On the screen.
It makes sense. Thank you.
It makes sense. Okay.
Yeah, it does.
Okay. Yeah, like
Yep.
like I said, it's one of those questions where you don't really learn it. Well, I'm showing you now, but like no one really teaches this in a normal mathematics class. It's like, yeah, most math teachers just let you just go struggle with it. If you know it, you know it. If you don't, you don't. You just skip it and move on to the next thing. And so literally that is going to be the separation of, do you get an A or do you get an A or an A plus, you know? So knowing how to work with it is very good. All right, so we have 3 more minutes. I don't think I can start with the number patterns. I will start. I'll just get busy with it, but then hopefully when you guys come back, I can just show you what I have so far, and we can carry on from there. But I think the number patterns is quite chilled. I'm getting the sense that it's quite chilled. You're given a linear number pattern in the beginning. The constant difference is easy. Term number 4, very easy. Calculate the number of terms. You just take the last guy. Yeah, very easy. I think the patterns guy, you guys should be able to do it. Yeah. In about 2 minutes, this call will end, and we're gonna start again at 6. And we're just gonna keep doing this, guys. I know it's a lot, it's too much math, but I really want to get you guys ready for those final exams. I will be setting those final exams, but yeah, I want it to be like at a, you know, national standard. And for you guys, if you want to go to varsity, those marks are really gonna matter. So I'm just really pushing you for that.
Right, thank you.
Cool. All right, cool. You can. It's gonna literally kick you out, guys. If you're gonna join again, you click on the second link, and we're gonna do as much as we can. Hopefully, if we can get to functions, finish functions, and that would be the end of the. What would be the end of today's objective? Just do the things that we haven't, that we have learnt already, and the other things that we haven't, we'll just leave until some other time.
Okay. See you tomorrow.
Cheers, Philip. Alright, see you at 10 past 6, guys. Aye. $17. So actually, the question was asking what term is 3 term 5 minus 2 equal to, and that is term number 17. You guys don't need me to go through it, right? What I did is I first, obviously we were given the 64 as term number 20, so I answered this question first. I got 21, I got 22, and that was 70. And then I took those three terms, and then I was like, ooh, I need the Tn of those three terms. So I substituted term 20 there, which is 64. Substituted the 20 for the n because it's term 20. And then what I was solving for is this a value. Then once I got a value as equal to positive 7, then I could go back into this formula here of the Tn, substitute the a value, substitute the d value that's given in the question, and then I got this guy as my Tn formula for that pattern. And now that I have the Tn formula, I then quickly calculated what term number 5 is, because I needed to know what that term is to find the value of this expression here, right? Then how did I find the value of that expression? I used it up here. 3 of the 19 minus 20 minus 2 gave me 55. But that still didn't tell me where is that 55. I need the position where that 55 is. So I'm going to put it back into my Tn formula for Tn. And what I'm solving is for this n here. So I'm taking the 4 over, subtracting, I get 51, divide by 3 on both sides. So it's actually term number 17. And that's what I'm doing there. Any questions about that? All right. Let's move on to the next part of this patterns, which is 3.3. So that is a quadratic. Find the next two terms of the pattern. 5, 12, 29. Again, I encourage you guys to try these yourself. So maybe let me give you a moment. These are very easy type questions. So try it. See if you know what is happening. Alright, so what it should look like is, what are we adding there? We're adding a 7. What are we adding there? 29 minus that guy is, let me check my calculator. I don't know. My brain has stopped working. I think that is 17. What are we adding there? 56 minus 29, 27. And so here I'm basically adding tens in each of these to get my second difference. So we would expect them to add a 10 to get 37 there. So 56 plus 37, 93. And I'm expecting them to add 47 there because they're adding a 10. And a 47 plus 93 is a 140. So those are my two next terms. Then 3.3.1, then 2, sorry, then asks us, let me check. It then asks us, prove that the first difference of this pattern will always be odd. So what is the first difference? The first difference is this guy here. And just by the looks of it, you don't really even need to do much calculations, because I mean, if it's a 7, a 7, a 17, a 27, a 37, and if you keep adding a 10, there's never going to be an even number, because I mean, you started with an odd and you keep adding a 10, and the 10 just keeps replicating more and more odd numbers. But what they did is they actually proved this with the formula. They found the TN formula for that pattern, and obviously it's a linear pattern. The second difference, remember this, first difference will always be a linear pattern. The first difference of a quadratic will be a linear pattern. So yeah, they did this formula here, n minus 1, which has a d there, and our d is the 10. Our first term is a 7, so we have n minus 1 with the 10 there, and if you substitute and expand those brackets, you get a 7 plus a 10n minus a 10, and if you keep going, this minus that guy would give me negative 3. So when they got this, then they realized that, ooh, since no matter what n value I can substitute there, whether it's even, whether it's odd, the fact that I have that negative 3 and I have that 10 there, it will always kind of give me a odd. So you can even try it yourself. Maybe substitute n as being even number, any even number like a 20, right? And then maybe substitute n as being like 21, and then compare those two. So T20 would be 10 with the 20 minus 3, and this will give us what? 10 times 20 minus 3, 197. So this is clearly even, but no, that's clearly odd. But T21, is that gonna also be odd? That should also be odd. Sorry, I think initially I said it should be even. So let's see, 10 times 21 minus 3, and that also gives me 207. So yeah, the fact that the 7 here is always going to be odd, and all of these guys, so since 7 is always going to be odd, always odd, it means every single term here will always be odd, because that last term would either be a 7, yeah, it will always be a 7 actually. Yeah, I hope that you guys are hearing what I'm saying. you can take any n values and compare those, and you will see it will always be an odd pattern. All right, let's move on to the functions part. Oh, is it still more patterns? Okay, it's still more patterns. All right, I thought it's functions now. So 4.1, we have a quadratic pattern, and you're asked to calculate T28, 26. This you can do, guys. This you definitely can do. Just need to find the Tn of that guy. Remember, with that Tn, there's these three formulas that you need to solve. A plus B plus C is equal to term 1 of the pattern, pat. The second one says 3A plus B is equal to term 1 of the second diff, or the first diff, sorry. There is no such thing as the second diff. This is the first diff. The last one is the one that's equal to the second diff. 2a is equal to term 1 of the second diff, second difference. Alright, so try it, guys. Take a moment. I'll just do it quietly because I'm also tired of talking now. This is a 2. So there we go. There's our A value. There's our B value. And there's our C value, and so therefore Tn is half n squared plus a half n plus a 2. Alright, so if you guys notice me making some mistakes, just let me know. But I think that should be correct. And so T26, you just substitute 26 there. So T26 is a half of 26 squared plus a half of 26 plus 2. And that does need a calculator. You get 353. Alrighty, so that was chilled. That was not that hard. We still have one more. Okay. A certain quadratic equation, a quadratic pattern, has the following characteristics. T1 is P, T2 is 18, T4 is 4 times of T1, so it's literally just 4 times of P. Let me just write it like that. 4 times of P. And T3 3 minus t2, they're telling you that it's a 10. This is a quadratic pattern, and they want the value of p. So if we were to write it out, it's a p first, then 18. Then we don't know what this guy is, but we know the next guy is 4p. And what we know is that we're given this difference here, which is a 10. And what we can find ourselves is this difference here in terms of p, which is going to be an 18 minus a p. Remember, it's always the next guy minus the previous guy. So that means if this is a 10, then technically this is 18 plus a 10, which will give me 28. And so now we can find this difference, which is a 4p minus a 28. Again, it's always the next guy minus the previous guy. But at this point, you still can't solve for the p unless you do the second difference, which is going to be a 10 minus an 18 plus a p. I hope you guys see why I'm writing it as plus p, because I'm saying a 10 is subtracting an 18 with the minus p. So this minus times is the 18, and it times is the negative p to make it a positive. So take note of your what do you call those guys? What do you call the word is the signs. Take note of the signs. Okay. So for this one is a 4p minus 28 that is subtracting a 10. That will give you a 4p minus 38. And now since this is a quadratic and this is our first diff, this is our first difference, and this is our second difference, the whole characteristic of a quadratic is that the second difference will be the same. So we can literally make this guy equal to this guy. And then we solve those guys. So this is, again, a very nice question. I love this question. Plus p is equal to a 4p minus 38. And this just gives me a negative 8. I'm going to take the p over. I'm going to bring the 38 to this side. It'll be a positive. And it's a 4p minus a p. And this is a positive 30. This is a 3p. Divide by 3. Divide by 3. And so p is actually equal to 10. So yeah, if you put it back into our pattern, it looks like 10, with the next guy being 18, with the next guy being 28, with the next guy being 4 times 10, which is 40. And there we go. Oh, finally we're done with patterns. We can move on to functions. So functions 5.1 is a parabola. No, not a parabola. It's a hyperbola. We haven't done hyperbolas yet. Yes, you would have done hyperbolas last year. If you've started 5.1, it's fine. But I want to skip 5.1, the whole of 5.1, because it's all about the hyperbola, of which I just want to wait until I do it with you to actually do that question. So I'm going to skip 5.1. I'm going to skip 5.2, which is also an exponential there. And I'm going to move on to question 6, actually. So yeah, we're going to just skip all of those, guys. If you started them, it's fine, guys. You can complete them. And then there's always the memo there, so you can always check yourself with the memo. All right, but with question 6, we are given f of x. I can see f of x. There's the equation of f of x. I can even see the graph of f of x. I think I need another white page. This is starting to write really slowly. Sorry for that. But again, guys, if you really need to follow the specifics, if maybe somewhere I missed you, or somewhere you're not really, or rather you're a little bit behind, it's fine. I will post this video again on YouTube, and you can always go watch it later on when you have the time. So f of x is equal to a 1 over 2x squared minus an 8. And what we're given is, we're given the coordinates of C, which is the turning point. Yes, C is the turning point of the other guy, of the g of x. And what else? We're given the A coordinate, which is the y-intercept of the G, same graph. So this is a beautiful question because we literally just did this today during our after school, that last period that we're doing. We are given a turning point, so I'm going to use this equation to solve for that equation of that parabola, and they want it in that form. So once I've done it in this equation, I just need to expand it to give it in the form they wanted, which they wanted in this form. So take note of that. Even though we are given the turning point, I do need to use that. There's no other way I can get it besides to use that equation, but at some point I need to expand it to get it to be the form that they wanted in. So let's quickly do it. I did say that if the turning point is given, the 2 and the 9, this is the same as a negative p with a positive q. So what does that tell me? It tells me that p is actually negative 2 and that q is actually a positive 9. I substitute those guys. So a open bracket x minus 2 squared plus a 9. Then again, I did say earlier on today that they will give you 1 point. Sometimes they give you an intercept, sometimes they don't. In this case, they gave us an intercept. We take that guy, we substitute it. So it's a 5 there for y, a 0 there for x, and we have something that looks like that, and we're trying to solve for a. So take note of what looks like an a and what looks like a 9. This is a 9 and that's an a. So if I keep solving, the 9 goes over, it subtracts. This is a negative 2 that is squared, which will give me a positive 4. And this is a negative 4. And if you divide on both sides by 4, a is a negative 1. And now I just need to glance into my graph. Does my graph correlate with the equation that I'm finding? Yes, my graph is downturning, so that equation makes sense. You always need to look at your graph, guys. Rationalize it. Does it actually make sense what you're doing? That's why I like functions, and that's why I like analytical geometry. Like anything that has graphs attached to it, or like a picture attached to it, you could always just look at the picture and see, does whatever I have algebraically make sense with whatever I have graphically? So this is how it looks like, but again, they said they wanted it in this form, so you need to expand that guy, and to expand that guy, you need to FOIL that. So I'm going to quickly FOIL it. You square the first guy. Remember this quick method I showed you? You square the second guy, you'll get a positive 4. You times them together, you'll get a negative 2x, and then you times that by 2. So this is a very nice method because in your exams, it's going to save you a little bit of time. But only use it if you really know the method. So if you're still not sure about the method now, then yeah, maybe first learn the method, get really good at the method before you start using it. So this negative 1 will multiply inside, giving me a negative x squared, negative 4, plus a 4x, plus a 9. And if you expand this, negative x squared, plus a 4x, wait, what did I write? Plus a 4x, plus a 5. So that's what I have. Is that what's in the picture? Yes, that's what is in the question, and we've shown it. So that's another thing that's nice about these show that question, that as soon as you get it, you just get this, this release of this, yeah, I got it. I've done it. I've made it. All right, so 6.2, it's not something we've done, but I can explain it now. It's quite easy. Average gradient is just you calculating the gradient between 2 points. Right, average gradient of G between A and C. So you use those 2 points. We have A, which is 0 and 5. We have C, which is 2 and 9. And we just need to calculate the gradient of those guys. So gradient, remember, is y2 minus y1 over x2 minus x1. And then if I'm calling this number 1, if I'm calling this number 2, then my y2 is 9 minus 5. And the other one is a 2 minus a 0. That will give me a 4 with the 2, and that is just a 2. So my average gradient is 2. Alright. Then 6.3 then says calculate the length of BD. Yeah, the whole point why they're giving us 5 marks is because this question is quite long. So what we need to establish is we need to solve for B first. And B is our x-intercept of f. So we need our f of x. There's our f of x, and we need to solve for the x-intercept of that guy. So let's quickly do that. We just substitute 0 for y. And you take this 8 over. You can do that for these 8 over. It's a positive. You times by 2 on both sides. I times by 2. I times by 2 to get rid of this half. Or another way to think about it is you're dividing by a half on both sides, which should still give you a 16 is equal to x squared. And again, square rooting gives you positive and negative. And so this is both plus minus 4. And what does that tell me? It tells me that actually the coordinates of B is a negative 4 and a positive 0. And there we go. Alright. I'm guessing you guys are still here. Oh, Emma is joining us. Welcome, Emma. We legit about to finish now. I think we're doing what? The last question, I think. But yeah. So maybe let me talk you through what I just... no, I don't want to. Emma, you can watch the recording. This is also being recorded. So you can always just watch the recording later if you want to catch up. So yes, guys, we've solved for the coordinates of B. But another thing that we need to do is we need to solve for the coordinates of D. So by the way, Emma, if you notice, we're already doing 6.3. There's a couple of questions we've skipped, so it's not like we've gone through the whole paper. No, there's some questions, like some of the function questions that I haven't taught you yet. We skipped all of those. So yeah, as I was saying, guys, we need the coordinates of D. But didn't we calculate the coordinates of D? We didn't. So we need to take that new equation that we got, the one that we just solved up here. Where is it? There's it there. Do you see this equation here? We need to take this and solve for the x-intercept of that guy. Remember, this is my g of x. I think that's my g of x, yes. I need to solve for the x-intercept of that guy. So let's do that quickly. 0 is equal to a negative x squared plus a 4x plus a 5. And times everything by 0 so that it looks kind of easy. Negative 4x, negative 5. And now you can easily factorize it without using your quadratic formula. Factors of negative 5 that add to give me a negative 4 is a negative 5 but with the positive 1. And so essentially x is equal to a positive 5 and a negative 1. All right. So, yeah. So what does that tell me? I think D would therefore be the coordinates of 5 and 0. And the distance of these, you don't even need to use a distance formula. You can see that, oh, the other one is 4 units to the left. The other one is 5 units to the right. So in total, they have to be 9 units apart. So BD is therefore 9 units. The distance of BD is therefore 9 units. You guys do see what I'm doing, right? A quick way of doing it is you always take the furthest one, the one on the right, so x of the D minus the x of the B, which will be a 5 minus a minus 4, and that should also give you 9 units. So that's how to do it. You always take the furthest one, subtract it from the one on the left. All right. Any questions, people? At this point, am I just speaking Greek?
I will go over the past paper by myself because I missed most of the lesson, but what I've heard now, it makes sense.
Okay, cool. That's fine, Emma. I hope the thingy went well. Did it go well?
Yeah, it did.
Alright.
It was like 5 hours long, but it was good.
Okay. Can you do CPR now?
Yeah, I do, and I also have like a certificate
Okay, that's
to
that's nice.
treat people.
That's nice. Cool.
Yeah.
Alright, the rest of you guys, people, just some feedback before I keep just blabbing and blabbing. It feels like I'm starting to not like these lessons because I'm literally just running my mouth.
It's making sense, thank you.
Okay.
Yeah, it is making sense, but I feel like maybe we should do the past papers
Beforehand.
and then, because then we can tell you what questions we need help with, and then
Okay.
we could do them all together, so then you don't have to do every single question that. Yeah.
No, I agree. And maybe if we do that, then maybe we can even make the sessions shorter, like an hour. Because I do feel like these 2 hours are laborious. And
'Cause-
yeah, as much as I love math, I enjoy these things. You can see me smiling during these sessions. But I also don't want to, be doing math so late in the evening, And at some point, my brain just stops working. So I agree with that. So maybe moving forward, maybe tomorrow, that should be the plan. I just send the past paper a week beforehand, and y'all work through it, and we use these sessions to delve deeper into these questions that might be difficult, and we keep it to an hour session. So that's great. That's feedback that I'm looking for. So thank you for that, Hannah. So yeah, let's keep finishing what we are doing. We have, I think, about 10 more minutes to go. So the next one, 6.4. Yes?
How much of the past paper did you get through in these 2 hours?
We did, so we did all of question 1, we did all of question 2, we did all of question 3, we did all of question 4, we skipped question 5 because those were all the hyperbolas and exponentials that I haven't taught you, and now we're doing question 6.
Okay, cool.
So that's an awful lot. But yeah, like Hannah said, I was literally going through each and every question. So yeah, maybe check out the videos, forward to the bits that you want to hear and just listen to those bits.
Okay, cool, thanks.
Cool. So 4.1.1 says, what is the value of f of x if it's greater than or equal to 0? So what does this mean? So this pictorially, let me show you pictorially what it means. So which one was the f of x? F of x is this one that is going up like that. Yeah, f of x is this one that is going up. So pictorially, they're asking, where are the x values where this function is above my x-axis? So we're looking for this range here. And where is my graph in that purple range? It starts there and it goes this side. And what is that point there? That point is B, of which we've already solved for that part, and there's a here. So literally where x is less than -4, that's all these guys this side. But it says equal to here, so we also need to say equal to or less than -4. So that's where it's above the graph. And then here, this is where the other intercept is. We also solved this. It doesn't have a letter there in the picture, but we solved for it. And where was it? Oh, there's it. Oh yeah, it was plus minus. So remember, it was plus minus. So it means this one was where it was +4, and now we're looking for the range afterwards there, because that's where your graph is above your x-axis. I hope you guys are hearing me, right? So here, the way you'd write it, you'd say greater than or equal to a +4. So that's what they're looking for that question. These two ranges here. And there we go. Very easy. So now they're asking 6.4.2. They're then asking, where is f of x, where is f and g both strictly increasing? So what does increasing mean? Let's get a definition of what increasing means. So increasing means as I increase my x values. Actually, let me write it like this. As my x values get up, as my x values increase, my y values are also increasing as well. So that's the definition of increasing. Let me write it here in English. As the x values increase, as the x values increase, the y values increase as well. And the inverse of that, decreasing, therefore means as my x values go up, as my values of x increase, my y values are decreasing. So this one is saying the inverse of that, slightly inverse. It says as the x values increase, as the x values increase, the y values are decreasing. So remember these definitions. The y values decrease. Remember these definitions because you're gonna need them. I will reiterate them at some point once we do functions, but yeah, this is a good time to take note of them and remember them. Put them in like some really nice column thingy, like a bubble thingy, so that it stands out, so that you remember it and it's part of your notes in your book, right? So now let's go back into the actual graphs. So let me redraw them this side. I want to just redraw them slightly just so we can visualize what's happening there. So how do they look? We have this, that is our g of x, and we have this, yeah, this is our f of x, and this is where b is, and we remember that is a -4, this is a +4, this is where D is, I forgot what was the D value. Just scroll up here. The D value was 5. So here we have actually 5 as our D value. What was this guy? That guy was -1. So this guy here is -1. I know it doesn't look like that, but yeah, just stay with me. So now let's just look at one of them at a time, right? We have the g of x there, and this is our f of x. So look at just f of x at a time. Do you see that as I move, as this purple thingy goes, the x values are increasing. I'm moving this side, so the x values are definitely increasing. But what's happening to my graph? It's getting lower and lower and lower. You guys noticed that, right? So what is happening to my y values? They're actually decreasing. So this f of x, as the x values are increasing, the y values, so in this range here, this purple range, it's actually decreasing. And then it gets to a point where it turns, it has its turning point there. And now as the x values keep increasing, they're still increasing in this way, but now the graph is starting to also increase. So that's what's happening with the f of x. The green part is where it's increasing, and the purple part, it's where it's decreasing. So another way to think about it, it's where it's going down. It's literally going down, right? Let's look at the g of x one. What's happening with the g of x? The g of x, as I increase my x values there, do you see I'm getting more x values? This guy is also increasing. Do you see it's going higher and higher? The y values are getting more and more. The more I change my x values and I keep moving them to the left. The more I keep changing them, they get higher and higher. And at that point, the turning point, they stop and then they start decreasing. Do you see, right? Everyone just heard what I was just trying to explain, right?
Yeah.
All right, cool. So now the question is, where are they both increasing? And so there's this part right here. Do you see this dotted line? I don't know what the turning point of this f of x is. We probably might need to find it to find where it starts changing to increasing, and what is this turning point of this g of x because between those is where they are both increasing at the same time. That's where they're both green at the same time. Do you guys see? So we probably need to go find those two turning points. And as soon as we can find those two turning points, and we only need the x values of those two turning points. As soon as we can find those two x values of those turning points, I think we have them somewhere. I'm trying to look for them frantically. Oh, we did have the turning point of the g of x. It was the 2 and the 9. So this one here, this g of x1, we had the turning point here. It was given in the question. It was a 2 and a 9. That's for the g of x. And the only one we're looking for is the x coordinate, actually. But now the f of x1, we do need to find its turning point. And with that, we're given the f of x graph. Let me check it again. Do you guys think it turns right there on the y-axis? I'm very what's the word? Tempted to say it turns right there on the y-axis, but I'm not sure actually. So maybe let me solve for it. All right, so how do you solve for turning point of this guy? Remember, you use this formula here, negative b over a 2a. Right, so let's quickly solve for it. We don't have the b, so our b is actually 0, and our a is a half, so it is a 0. Yes, so we were right. We could have just trusted ourselves. But yeah, no, we needed to do some math. We can't just trust ourselves. So yeah, we do know that that turning point is actually happening right there on the x and the y axis. So the green starts changing there. So literally the range we're looking for, is from 0 to positive 2. How do we write that in terms of an inequality? X is less than 2, but x is greater than a positive 2. That's where both of these graphs are actually increasing at the same time. All right. Does that make sense, people?
Yeah.
It does.
Okay, cool.
Yeah.
Yeah. So, I'm a bit beat now. I don't know if we should move on to the next guy. What I am gonna give you guys to do is, because we do have like 1 more minute before this ends, actually 12 more minutes, is please maybe use whatever time you have this evening to do the financial math part. Use whatever time you have this evening to do the financial math part, which is question 8. And then, yeah, you can always mark yourself with the memo. But at this point, I do want to call this to a close. I'm tired. I'm hungry. I want to stop. So, yeah, guys. Unless you guys have any other clarification questions, then I will dismiss you guys. You can therefore go and do whatever you need. And plus, you guys still need to go draw my parabolas for tomorrow. So maybe focus on that as well. It's a lot of math happening, I know. Tomorrow we're even doing statistics. So it's like concept on top of concept on top of concept. But I hope you guys are keeping head above water. And yeah, just speak out. Ask for help. I really, really am here for you guys. I want you guys to succeed. I want the best for you guys. So yeah, literally, that's why I'm sacrificing my Thursday evenings. It's not like I have nothing better to do. It's because I want the best for you guys. So yes, Tyler, do you have a question? Are you just saying bye? Oh, that was an accident. Okay, cool. So yeah, let's call it, guys. It was nice.
Thank
I will
you.
see you in the
Appreciate it.
next one. No problem.
Thank
We'll
you
see
so much.
tomorrow. Bye, guys.
Bye.
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 Thank you.
Bye.
Bye. Thank you.